In the past, developers had multiple technologies to choose from to add communication to their applications. For example, there was .NET Remoting. It gave you a TCP/IP communication channel where you can send binary data across app domains. There was also an early model of web services referred to as ASMX. It allowed you to have HTTP communications across an XML formatted message in SOAP format. There was also a wrapper named Enterprise Services that encapsulated what used to be COM Plus and DCOM. Of course, you always had the TCP/IP communication stack if you needed low-level raw communications capability. The dilemma that developers faced in this time period was which technology is best for what I want to accomplish. Each had its pros and cons. Microsoft saw this and they developed Windows Communication Foundation, WCF. WCF gives you a single unified programming model for communication that pulls together what all of these other technologies did so that you can have a common standard way to accomplish what you need. The capabilities of WCF allow you to build distributed and connected systems. More specifically, you can accomplish various things. One example is publish-subscribe, where you have a service that publishes data, and then you have a client that wants to consume that data. Another scenario is communication between systems. The main focus here is that the systems can be either both .NET or they can be different platforms. For example, a Java service can talk to a .NET service. Because of open standards, you have the ability to communicate without problems between the two systems. You also have the ability to expose enterprise and web APIs. Within the enterprise, you can have different systems expose their capabilities as services, available to any other systems in the company that want to consume those services. Like, say for instance, I have an order processing system and I need customer data, I need past ordering data for clients, and I need maybe the credit history, and so on. What you can do is you can wrap each one of these types of systems in a web service, and then various other systems around the company can consume them for whatever they need. Another popular API strategy is based on the REST architectural model. You can see this around the web today in systems like Twitter and Facebook and so on, where they expose their data and allow you to post statuses and various types of things just by using an HTTP URI. This is very powerful, and WCF supports that too. Now, more specifically on standards, WCF supports what's called WS* standards, and these standards are maintained by an organization known as OASIS. OASIS is a consortium of different companies that have come together and agreed that these are the standards that we need to make computing systems interoperate. What I want to do now is show you the OASIS site and some of the standards that WS* and WCF supports. Now we're at the OASIS site. You can see in the address bar that it's oasis-open.org. If you go to the About page and select Organization, you can see that OASIS means the Organization for the Advancement of Structured Information Standards. Going to the Standards page and selecting Approved OASIS Standards gives you the entire list of their standards. If you scroll down to the W's, you can see all of the WS standards here. Here we have WS Discovery, Federation, Security, Reliable Messaging, Reliability, Secure Conversation, Trust, and Transactions, and so on. What these are is building block standards where organizations can increasingly add new types of capabilities to their services to improve the interoperability and improve the services that they offer. Now we'll discuss web service building blocks, which includes metadata and message formats. When considering metadata, you have to think about a couple different formats. One is WSDL and another one's called metadata exchange. But essentially what metadata allows you to do is to have a computer representation of a service and what its capabilities are. The first metadata format that I want to discuss is Web Service Definition Language, often referred to as WSDL. This is a standards-based way to expose a service's capability. It's cross-platform and implemented by many systems that support web services today. Another metadata format is metadata exchange. And metadata exchange allows you to discover web services, their contents, and what their capabilities are. There are many message formats supported by WCF. For example, there's SOAP, which is an XML format that's specialized and has a header and a body, and it supports the WS star standards. You can also format your messages as just plain old XML. You can format them as JSON or binary, or you can use a standards-based binary format called Message Transmission Optimization Mechanism, MTOM. Of course, you can always have your own custom format because WCF is extensible. Now let's go see what WSDL looks like. Here we have a WCF service application open in Visual Studio, and the reason I have it here is because I want to go in and I want to find the WSDL and show it to you. Here's how. Right-click on the project name, select View in Browser. This will give me a list of files that's in this project, and I'm interested in this file with the .svc extension. I'll click on that, and I get this nice helper page. What's interesting about this page is this single WSDL link right here. WSDL files can be broken up into many pieces, but the single WSDL goes and pulls those pieces together into a single document. When I click on it, I get the document. You have all these different XML namespaces and so on. You have a target namespace, and this tempuri.org is a default namespace name. This is the name of the service. That's also a default name that happens when you create a new web service project in Visual Studio. What's really interesting about this WSDL are these sections. You have a type section, various message sections, a port type section, a binding section, and a service section. Each of these sections from the top down are essentially building blocks and inputs to the next level. For example, the types. Let's look at a couple of these. I have a type and it's named getData. This name is just a unique name so that I can use it later. Its type is int. Here's getDataResponse. Its type is string, and so on. we have these get data using data contract, which is based upon a composite type. And if I scroll down here, then I can see the composite type, which has a bool and a string value. Now, the previous examples of types were primitive types. However, these composite types, they correspond to classes in .NET. Now, the messages. Here's a message, and it has a unique name, because this message will be used again later. But the type of the message is the getData type. Looking at the next message, it also has a unique name. Its type is getDataResponse, which you saw was a string. If I scroll down here, I'll see how messages are used. See the port type? See the iService1? iService1 is the default name that WCF gives a service contract when Visual Studio first creates the project. Inside of this contract, which is an interface in .NET, you have operations. And this operation has the name getData. Operations correspond to methods, and this method is named getData. This operation has input and output. Input corresponds to parameters to the getData method. Output corresponds to the return type of the getData method. The input is getData. Again, that's the getData message, which has a type of int. The getDataResponse is the getDataResponse message, which is a type string. So that's that operation. Here's another operation, getData using data contract, which has input and output, and both the input and output are the getData using data contract, which is the complex type that we saw earlier as both the input and the output. So now you have a contract, which is a .NET interface with two operations that are .NET methods, and they have types. Now you have the definition of the service. Next, we want to look at the binding, and the binding defines how the communication takes place. For example, we're using SOAP as the protocol. And so we have to define the communication for both of the operations. Here's getData and getData using data contract. In SOAP, you have different types of format. For example, we commonly use document. There used to be a format called RPC, which was more a request response type scenario. However, services are often document centered. For example, a document could be an invoice, a purchase order, and so on. The body type literal means that when we build this XML SOAP message, that we're going to take the document and put it exactly as is in XML format in the body of the SOAP message. There's another format called encoded that puts a lot of metadata on the XML and is less readable and is kind of discouraged in the standards-based WS-Store world. Finally, we have a service right here. And here you can see that the service says, oh, okay, I'm based on this port type, which is the name of that interface that we saw in the port types. Here we have a binding, and that corresponds to the binding. And here we have an address. Or said another way, we have an address and a binding and a contract, which defines an endpoint. An endpoint is something that defines the service itself. So these are the ABCs of web service endpoints: address, binding, and contract. And now you see how the WCF uses this WSDL document to define a web service in .NET format. Other technologies will use this WSDL document to translate the definition of that service into the implementation of their own technology. And there you have it, Web Service Definition Language, WSDL.